What's going on, guys? Welcome to this in-depth tutorial on Linux file permissions and access controls. If you're new to Linux or looking to strengthen your understanding, this video is going to cover the core concepts of how Linux handles file and directory permissions. So we're going to explore basic file permissions and also deep dive into more advanced concepts like sticky bits, SUID, SGID, and access control lists to provide you with tools needed to fine tune your permission management. So let's go on and get started. So Linux uses a permission-based system to control who can access files and directories. This system is one of the foundations of Linux security, making it more essential for administrators and users alike to understand how permissions work. All right. So in Linux, permissions determines what actions users can perform on files and directories. There are three basic types of permissions. There is the read permission. This allows users to read the contents of a file or list the contents of a directory. The write permission. This allows users to modify or delete contents of a file and or remove files within the directory. The execute permission. This is going to be for executable files, i.e. programs or scripts that you may be wanting to run. And for directories, it's going to allow users to enter into the directory and access its contents. Once again, so these permissions are assigned to three categories: the user, which is the owner of the file; the group, which is a group of users who shares the common permissions for the file. So if the group has it, anyone in the group will be able to read the contents of the file if it has read permissions. Same thing for write and executable permissions. Others, this is going to be all others on the system who aren't the owner or part of the group. Okay, so to view the permissions on a file or directory, you're going to use the ls-l command, like so. This is going to list all the files and directories in the current directory that we are in. To get more specific, you can just do ls-l, for example, the chair file, and then it'll give you the permissions for that file specifically. So this shows the permissions for the chair file, and you can see that the owner in this box here, if the owner is John and the group belongs to John. Okay, and you can turn your attention to the left side of the screen here where you see read, write, R, and then no permissions here. So these first three right here, the R, W, and then the slash, this is going to be read, write, and another permission if you want to set it. So this is going to be the user's permissions right here, this first three set. The next three set, which is going to be for the group. So the group is going to have only read permissions. And then everybody else for this last three bits is going to only have read permissions as well. All right, so now we're going to go over modifying file permissions using the chmod command. The chmod command is going to allow you to change permissions for files as well as directories. So you can use either symbolic mode or numeric mode to modify permissions, which we're going to go over both of these. So first off is going to be symbolic mode. You specify the user, U is for user, G is for group, O is for others, and A is for all. And then you're going to use the operators plus or minus to remove or add permissions and equal to set permissions. So we're like so. We're going to do, let's list out the files. We're going to do chmod user. We want plus, let's do execute for chair. And then ls minus l chair. You remember before we only had read and write executable permissions. Sorry, we only had read and write permissions on the chair file, and now we have read, write, execute for just the user. For others, we can remove permissions. Mod O R and then chair. Let's see. Yep. And the read permissions is removed from the other portion of the permissions. All right, so let's see setting permissions. So let's do chmod. What do we want to do? We'll do group and others will equal read and write for share file. Proof of concept and others and group has the read and write permissions. All right, so moving on to numeric mode. This is where we're going to assign numbers for permissions. So the read is going to equal to 4, write is going to equal to 2, and execute is going to equal to 1. So we're going to give some proof of concept here. So let's do ls minus l. Let's see what files we have. Let's do the table. So chmod 7. Let's do, and it's the same thing for this. There's going to be users. It's going to be user, then group, and then others. Let's do 7 for read, write, execute, 4 for read, 4 again for read, and we're going to do that for, actually, let's do 6 for read and write. We're going to do that for the table file. Proof of concept. And we have read, write, execute, read, write, and read, write. All right, now let's change it to read, read, and read for everybody. Proof of concept again. And it's read and everybody's only able to read the file. The user, the group, and everyone else. Okay, so Linux file ownership determines who can modify the file. So we're going to be using the chown and the change group command to modify ownership. So first, let's use the chown command. All right, ls minus o. Okay, as you can see, root owns these files and directory, and this one directory fruits. And it also is the group as well. The root group owns this file as well. So what we're going to do is we're going to change ownership. So you're going to do chown, the new owner. For me, I'm going to do Mike, and then you do the file. And then proof of concept, ls minus l. Yep, and Mike owns the file, but the root group owns the file as well. All right, so the change group command. This command is going to change the group of a file or directory. So we're going to do ch group. Let's match it. We're going to do the new group. We're going to do the Mike group is going to own this file data as well. Now let's minus L for proof of concept. And Mike, the user owns it, and the group Mike owns it as well, owns the data file. So now let's talk about directory permissions and special permissions. Directories have special permissions that govern how users can interact with them. For example, the execute permission on a directory allows users to enter into the directory. So without execute permissions on a directory, you cannot enter or access the files inside it, even if you have read permissions. Write permissions allow users to create or delete files within the directory. So now let's move on to our special permissions, the sticky bit, SUID, and SGID. So these special permissions are going to provide additional control over files and directories that are a little bit extra than the common read, write, and execute permissions. So these permissions are not just about controlling access, but it's also about controlling how files are executed and managed as well. So the sticky bit is used on directories to ensure that users can only delete or rename their own files, even if they have write permissions to the directory. This is commonly used for directories like /tmp, the temp directory, where multiple users may have write access but shouldn't be able to delete each other's files. So Let's do this minus L, do chmod. This is how we're going to place a sticky bit on the file. So let's do chmod plus T data. And then you see here at the end, there's a T permission, meaning that only Mike can delete the data file. All right, so let's do ls minus L. Let's do chmod plus T for sticky bit. And we'll do the profiles file. Let's do ls minus L, profiles. And you can see at the end, there's a T. And that's going to be your sticky bit. So only the root user can delete this file, profiles. Moving on, the SUID bit and the SGID bit. So the SUID bit is used on executable files. When a file with the SUID bit set is executed, it runs with the privileges of the file owner, not the user who was executing it. This is useful when a program needs elevated privileges to perform certain operations. Example, chmod plus chmod u still group plus s. All right. And then we can see this S here is for the sticky bit. So now if let's say this data file was an executable file, now any user, all right, so since we set the sticky bit on the data file, now this means that when any user runs this data file, let's say if it was a script, it's going to run with the privileges of the root user. So this is going to be allow them to modify this data file even if they're not root. Go back. Let's just go back. All right, so moving on to the SUID bit and SGID bit. So the SUID bit is used on executable files. When a file with the SUID bit set is executed, it runs with the privileges of the file owner, not the user who is executing it. So this is useful when a program needs elevated privileges to perform certain operations. So let's show a little bit of proof of concept. All right, so this command set the SUID bit for the fruits directory. So you can see it has the S bit right here. So now when a user runs this directory, they're going to be able to do so with the privileges of the root user, allowing them to modify and enter into the directory as well. So why is this useful? This is useful for system commands that need to run with root privileges but don't require the user to have full root access. So here's some security considerations to be aware of. So you want to be cautious when you set this SUID bit as it's going to grant elevated privileges. So always review which files have SUID bits set and ensure that they are trusted. If if the wrong file is set for SUID, you might not want other users to access this file or make modifications to it, i.e. a configuration file, for example. Moving on, the SGID bit works extremely similar to the SUID bit, but instead of giving the process the owner's privileges, it gives the process the privileges of the files group for directories. SGID ensures that files created within the directory inherit the group of the directory rather than the user's primary group. Let's do fruits again. Then you can see here the S is set under the group's permissions. So this command set the SGID bit on the fruits file. Now, if it was a directory that we set, any files created in that directory that we set the bit on will automatically have the group of the directory instead of the user's default group. So why is this useful again? SGID is often used on shared directories where all files should belong to the same group, making it easier to manage permissions and access in collaborative environments. For example, if you have an accountant group, you want everyone within the accountant group to access the same files within the directory and certain directories that you want this group to have access to. All right, Linux access control lists. So this is going to be some advanced permissions using the ACL command. This is going to provide a more fine-tuned level control over the file permissions that the basic owner group other model does not have. So ACLs allow you to assign permissions to specific users and groups in addition to the file owner. Let's list out the directories that we have here. We have the data file, the fruits directory, and the profiles file. Let's get FACL data. All right, now this output is going to show the file's owner, group, and default permissions. And you can also see the specific access control lists applied. Now, why might we want to configure and set access control lists on a file or a directory? Now, let's say, for example, we have user A and user B. User A has read, write, and execute permissions, and we want user B to have read, write, and execute permissions for a file as well. However, the group will just, let's say the group has read permissions and everyone else has read permissions as well. So we might want user B to have read, write, execute permissions as well as user A, despite them not being a part of a group or everyone else that has those types of permissions. And we can get specific with how we want to apply these permissions across different files and directories. The setfacl command is used to set access control lists for files and directories. Like so, setfacl. The syntax is going to be -m to modify, space U for the user. Let's do Mike permissions is going to be read, write, execute, and we'll do this on the data file. And let's see the permissions as well again. And the user Mike has read, write, execute permissions. Now you guys can see how useful this command may be to get specific with the different permissions that you want to set on different users. Now to remove an ACL, we're going to use the -x option with set facl. So set facl -x user, U for user, Mike, and the data file. Once again, let's check. Get facl data. And Mike is no longer there for specific read, write, and execute permissions. And there you have it. A comprehensive deep dive into Linux file permissions, sticky bits, SUID, SGID, and access control lists. By mastering these permissions, you'll have fine-grained control over your system, allowing you to manage file access and execute files securely. Remember, understanding and managing permissions is one of the most powerful tools in Linux for keeping your system secure. Always, always, always double check your configurations, especially when dealing with special permissions like SUID and SGID. Now, if you found this video helpful, please like, comment, and subscribe for more Linux tutorials and system administration tips. I'll see you in the next one. Bye.